Yes. So let's get started. All right. So let's, before we go to the next topic, let's quickly run through the current problem sheet. All right. So we are at problem number 3, right? This question. Right. So we are done with problem number 2, and this is sheet number 5. This is problem sheet number 5. And we are on problem number 3, right? So you have a copy with you, right? You have a copy of the problem sheet with you. So the solution of the equation ax plus b is equal to cx plus d, where a, b, c, d are constants. B not equal to d, a not equal to c. Okay, so we are still discussing linear equations in one variable. Okay, so far we have seen different types of linear equations which can be solved just by addition or subtraction, and there are linear equations which can be solved just by multiplication and division, and there are linear equations which needs to be simplified by combining the like terms, expanding the brackets, and things like that. So those are multi-step linear equations. And currently we are discussing linear equations which have variables on both sides, right? So we are on question number 3 now. So this is the kind of general equation that you will encounter. Ax plus b is equal to cx plus d. So this is a kind of general expression that you will often see, because we have a linear expression on left hand side, another linear expression on right hand side. So the idea of solving this is bring the variable to one side, bring everything to one side. So we have ax minus cx. Of course, the numbers go to the other side. So that is d minus b. And this is a minus c times x, which is equal to d minus b. Now your x is nothing but d minus b divided by a minus c. All right. Now this could also be written as, see, if you multiply with a negative sign on both numerator and denominator, this could be very well written as b minus d divided by c minus a. Don't you think so? Right? Say your 3 by 5 could be very well written as minus 3 divided by minus 5. Yes. Cool. So this is a generalized equation, and in this case what you need to understand that you can have constants appearing in equations. So in this case we call a, b, c, d as constants. Okay, of course these may take different values in different contexts. That is possible. Okay, so instead of constants, these are generally called as parameters. Okay, you might have heard the term parameters, right? So what are parameters really? See, suppose you have recently learned about functions. You have recently learned about functions. Have you learned about functions? What about Prisha and Robin? Have you learned about functions? Yeah. Function is basically you have a black box. Think of it as a black box. Feed some input to it, and then it gives you some output. The only thing is when you give one input, it just gives you one output, right? So you have different kinds of functions. For example, a linear function would look like something like this, say 2x plus 3. Y is equal to 2x plus 3 will be a linear function, right? So in this case, your x is called the independent variable. And your y is called the dependent variable. And this is called a linear function. Of course, you can also write y as f of x. Okay, so f of x signifies that f is like something which operates on x and gives y as the output. Okay, so this just signifies that your f is being operated on a variable x and you are getting y as the output. Right? All right. So tell me, if you go and try to plot the graph of this expression, y is equal to 2x plus 3, with your x values on your x-axis and your y values on the y-axis, what will be the shape of the curve you will be expecting? What is the shape of the curve? What will be the shape of the graph that you will be expecting? Can you tell me? Yeah, what about others? It is going to be a straight line, right? It is going to be a straight line. It is going to be a straight line. Yeah. Hence the name, the linear function, because this is going to generate a straight line for you. All right. You just maybe take your graphing calculator or maybe pick up a graphing software. You just go and plot y is equal to 2x plus 3. This is going to give you a straight line, right? That's cool, right? You're familiar with this idea. Yes. Yeah, okay. Now, suppose if I generalize, see, I don't know why I'm not able to add a new page. Suppose instead of y is equal to 2x plus 3, if I write this as y is equal to mx plus c, y is equal to mx plus c, we call m and c as constants or parameters. Okay, you can call this as parameters. Okay, and what is the role of this parameter? Now, if you fix the value of c, if you fix the value of c, it is going to give you a family of a class of straight lines. Okay, so for example, if I'm going to fix the value of c, if I say y is equal to mx plus 2, mx plus 2, what does this signify? Y is equal to mx plus 2. What does it signify? I'll show you this. Please listen carefully. Now I'm going to set my parameters as m and c. And if I plot y is equal to mx plus C. Now suppose I fix my C at, say, some value 3. Look at the graph. If I fix my value at C is equal to 3, and if I vary my M, so this basically generates a family of straight lines. You have different straight lines for different M, but you have fixed C is equal to 3. We have fixed C as a constant number 3. Okay. So that will make sure that a straight line always passes through this point, which is 0, 3, right? A straight line always passes through 0, 3. Right? So the idea is very simple. When you have a straight line, y is equal to mx plus c, your m and c can keep taking different values. That's not an issue, but we are going to call them constants, or rather parameters. Okay. So so it is going to generate different families of straight lines. That's all. Okay. And for a different, a particular value of m and c, suppose you choose your m and c as 2 and 3, you have the straight line. You have y is equal to 2x plus 3. If you choose your m and c as 2 and 3, you're going to get this straight line. And in the straight lines, if you keep giving different x values, you keep getting different y values. So these are what we call the variables. These are the variables. Okay. And this is generally called as the independent variable. And this is generally called as the dependent variable. Okay. So the idea is simple. It is possible that a linear equation can have constants or parameters showing up in the equation. So there's nothing to worry about that. All right. So when that constant takes different values, it keeps generating different types of functions or different types of equations or different types of expressions. Right. All right. So let's get back to this. Yes. So our next question number 4. If half alpha plus 6 is equal to minus alpha minus 3, what is the value of minus 2 alpha? So how do we do this? Bring everything to one side, bring all the variables to one side. So we have half alpha and minus alpha. When it comes to the left side, it becomes plus alpha. Okay. Now we have 6 going to the other side. It is going to be minus 3 minus 6, which will be minus 9. And what is half alpha plus alpha? What is half alpha plus alpha? It is, you can write it as either 1.5 or 3 by 2. So this is 3 by 2 alpha equal to minus 9. Yes. So our alpha will be minus 9 into 2 by 3. Your 3 and 3 can be cancelled off. You have alpha is equal to minus 6. Alpha is equal to minus 6. Now they have asked for minus 2 alpha. So our answer will be minus 2 into minus 6, which will be 12. 12 is our answer. All right. It's an easy question, right? It's an easy question, right? But I'll tell you this, these kind of questions do come in your SAT. The idea is you have to crack it in 10 or 20 seconds. Okay. So such silly questions do come in SAT. The only point is you have to crack them in 10 or 20 seconds because there will be questions which might take 2 or 3 minutes, right? Now let's look at the next question. Let's look at the next question. You have 9y plus 8 by 3 is equal to 8 by 3y plus 9. And the question talks about 3 by 8y. So our question is 9y plus 8 by 3 is equal to 8 by 3y plus 9. See, this is a tricky question. I mean, this can be done in the normal way, but if you just think you can do it in maybe 2-3 seconds, I'll tell you how, but let's do it in the regular way first. Okay, the regular method is bring everything to one side. So we have 9y minus 8 by 3y is equal to 9 minus 8 by 3. Okay, so we have 9 minus 8 by 3 times y is equal to 9 minus 8 by 3. Now, if you simplify this, 9 is going to be 27 by 3. This is minus 8 by 3, y is equal to 27 by 3 minus 8 by 3. So this is going to be 19 by 3, y is equal to 19 by 3. Okay. And now you can cancel off 19 by 3 on both sides. Your y is 1. Your y is 1. Right? So this is clear. This is clear, right? But you don't have to do all these steps. See, observe this question. Observe the question. Have a look at this question. Just stare at it for some 10 seconds. You stare at the question for 10 seconds and it is immediately understood that y is equal to 1 is a solution. Why? Because when you put y is equal to 1, this term is going to be 9 and there is a 9. And when you put y is equal to 1, this is going to be 8 by 3 and there is 8 by 3. So you can immediately observe that y is equal to 1 is a solution. That should strike you. Okay. That should come naturally. Is this clear? When you look at the question, you should be able to say that, see, y is equal to 9, 1 is going to be a solution to this equation because when I just imagine y is equal to 1, it's going to satisfy the equation. Both LHS and RHS are going to be the same thing, right? Are you getting this? So have you thought about this before? I mean, just by staring at the question, have you realized that y is equal to 1 before? Such observations will help in your SAT. Because, most of the times you may not have to actually solve this question. Attention to detail and your observation skills will help. Okay. So when you see this question, how do you come up with such a intuition? See, when you see this question, you observe that there is something peculiar about the question. What is so peculiar about this question? There is 8 by 3 showing up. There's 8 by 3 showing up here. There's 9y here. There's 9 here. So it sounds like, looks like when you put y is equal to 1, this is going to satisfy this equation, right? This is fine, right? Right? See, my point is, apart from the regular methods, apart from the regular way of solving a question that you learn in school, you should also know these kinds of sneaky ways, sneaky approaches, these shortcuts, these observations, which is going to save you a lot of time. So your value of y is nothing but 1, and your 3 by 8 y is going to be 3 by 8. Now, in this question, what can you observe? What can you observe without doing any math, without writing down a single step, without writing down a single step? Can you quickly say that? Can you quickly say that? What is the solution? Just think and tell me what is the solution without writing down anything. What is the solution? Is this confusing? Tell me. Just look at the question and tell me what is the solution. I don't see a response. Are you guys confused or thinking, or you don't want to reply because it's too easy? Hello? Hello, am I audible? Are you with me? Yes, thinking. All right, think. Yes, no issues. Just think, look at this question, and tell me what comes to your mind. There is something peculiar about this question, right? There is something peculiar about this question. So think about it. Think. No, see, you can't set your own restrictions on parameters. You are trying to find the value of x. You're trying to find the value of x. X is your variable. As I said, a and b are like constants. A and b are like constants. Okay. Yeah, that is cool, right? You just observe that when you set x is equal to 1, when you set x, see, b is equal to a, b is equal to a, it's not possible because it's given in the question that b cannot be equal to a. So forget about that, right? It is given in the question that you can't put a equal to b. Of course, if you put a equal to b, that is being satisfied, irrespective of the value of that. We'll come to this idea later on, okay? We'll come to this idea later on. But for the time being, understand that if you put a is equal to b, if you put a equal to b, what happens? This is going to be ax plus a equal to a plus ax, which is unconditionally true, irrespective of the value of irrespective of the value of x, it is always true. So it can have so many solutions. It can have infinitely many solutions. We will come to this topic later on. But for the time being, they have given that you can't set a equal to b. It's not in your hands. But your question, your question is to find the value of x. Now, as Olivia said, Why don't you just try and put x is equal to 1? What happens to that question now? Why don't you just try and put x is equal to 1? What happens to that? Tell me. What is the answer? LHS is a plus b and RHS is? LHS is a plus b and your RHS is? When you put x, yeah. So it satisfies, right? It satisfies, right? So when you put x is equal to 1, it is being satisfied. The equation is being satisfied. So that value of x, which satisfies our equation, is what we call the solution. So what is the solution to this equation? What is the solution to this equation? What is the solution to this equation? It's x is equal to 1. What about others? Are you with me? Are you with me? It's x is equal to 1 because, yeah, cool. Great. So if you had solved it in the regular way, the normal method, if you have ax plus b is equal to a plus bx, a plus bx. So bring all the x terms to one side. So I'll bring bx to the other side. Take b to the other side. It becomes a minus b. So we have a minus b times x is equal to a minus b. And your x is equal to a minus b divided by a minus b. Since it's given that a is not equal to b, a minus b will not be equal to 0. So since it is a non-zero number, you can easily cancel these off and you get 1. Okay, this is a regular way of doing it. But my point is, when you look at the question, what should kick in? What should be our immediate thought? What should be our immediate thought? Oh, there's something peculiar about this question. Look at the coefficients. There's something peculiar about this question. So there has to be something peculiar about the answer as well, right? And interestingly, if you put x is equal to 1, it is going to be a solution. Without actually solving it, just by looking at the question, you should be able to call x is equal to 1 as a solution, right? So far, so good? Yes, cool. Okay, then this question. Again, I don't want you to write down. I want you to just look at the question and just by observation, can you tell me what will be the solution to this equation? Just don't write anything down. Just stare at the question for 5 seconds. Just stare at the question for 5 seconds. Our idea is to find the value of x that will make this equality true. What value of x is going to make this equality true? What value of x is going to make this equality true? Yes, very good, very good. Just think, Prisha. Just think. It is going to be 0, right? Because you have 3 and 3. And what do you observe? If you set x is equal to 0, it is going to be satisfied. Cool. See, that is the power of observation. Okay. Without moving your pen, in just 2-3 seconds, just by looking at the questions, just by observing the numbers, just by understanding that there is something peculiar about these numbers, You got the answer. Yes. So our answer is x is equal to 0. How do you do otherwise? How do you do it otherwise? You just cancel off 3 on both sides. You have 2x is equal to 4x. Take 2x to the other side. We have 0 is equal to 4x minus 2x, which is 2x. So your 2x is equal to 0. So your x is going to be 0 by 2, which is 0. This is the regular approach. But we don't want to waste time writing down so many steps. Do we? We don't want to waste our time, right? All right, next question. So let's do the next question. We have 16 minus 7u is equal to u plus 14 minus 6u. 16 minus 7u is equal to u plus 14 minus 6u. So idea is to bring every variable to one side and bring all the numbers to the other side. So I'm going to bring this 7u to the other side, take 14 to the other side. So 16 minus 14 is equal to 7u plus u minus 6u. So we have 2 is equal to 8u minus 6u is going to be 2u, and u is equal to 1. U is equal to 1. Yes. And your u minus 1 is going to be 0. U minus 1 is going to be 0. Cool, right? Okay, I'll tell you this, with a lot of practice, see, you will be able to find the solution much quicker. In some of the cases, without actually moving a pen, without actually writing down any step. Because, in this case, u is equal to 1 was the answer. If you could observe that 16 minus 7 is nothing but 1 plus 14 minus 6. You could have easily said that u is equal to 1 was the solution. If you could observe that 16 minus 7 is nothing but 1 plus 14 minus 6. You could have easily said that u is equal to 1 as a solution, right? But that comes through a lot of practice, okay? So don't worry about it. But for the questions we just saw previously, the previous one, those were easy ones. So just by observation, you should be able to figure out stuff. All right. So this is fine. Yes, cool. Let's go to the next question. Ninth question is 5x minus 2 into 2x minus 7 is equal to 2 into 3x minus 1 is equal to 7 by 2. Yes. So you have a multi-step equation here, and you have variables on both sides, and you have also brackets, parentheses coming in the equation. So you need to expand those brackets first. So we have 5x minus, this is 2 into 2x. See, you should be very careful here because there is a minus sign. This negative sign will also be distributed. Okay, this negative sign will also be distributed. So this is going to be minus 4x. Minus 2 into minus 7 is going to be 14. Right? On the RHS, we have 2 into 3x is 6x. 2 into minus 1 is minus 2 plus 7 by 2. Yes. So let's simplify this. This is going to be x plus 14 is equal to 6x minus 2 plus 7 by 2. So let's bring x to the other side and take all the numbers to the other side. So we have 6x minus x, and along with 14 we have plus 2 and minus 7 by 2. So this 6x minus x is going to be 5x. This is going to be 16 minus 7 by 2. 16 minus 7 by 2. Why? I added these two terms. Now let's simplify this fraction. How will you simplify this fraction? We have 2 as the common denominator. 16 into 2 minus 7 is equal to 5x. So this is 32 minus 7 by 2. That's equal to 5x. 32 minus 7 is going to be 25. 25 by 2 is equal to 5x. So you can just cancel off 5. This becomes 5. And your x is equal to 5 by 2. Tell me if this is all right. If you're stuck at some point, do let me know. If you're stuck at some step, do let me know. If you're stuck at some step, the first step involves bringing everything to one side. Second step, third step, fourth step, fifth step. If you're stuck at some point, tell me. If this is all right, do let me know. Just say this is all right, and then we'll move on to the next question. Hello, 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 hello. So that's all right, right? Yes. Robin? Yes, cool, cool, cool. That's very cool. Let's go to the next question. See, we have decimal numbers in this question. See, I'm trying to give you all varieties of questions. Okay. Again, it's about doing these questions multiple times before your actual SAT. Okay. I'm trying to generate a lot of questions for you. Our idea is to do a lot of questions because, the only way to learn math is by actually doing math. See, in this problem sheets, I'm giving you the solutions, but I strongly recommend that you do it with on your own before actually looking at the solutions. Okay, I don't recommend looking at the solutions. The solutions are there because you can use them maybe later on, because you will be writing your SAT maybe 18 months from now, right? So I guess you're going to write your exam in 2022. Yes. So you can keep these sheets with you. You can keep revising. You can keep practicing. Okay. That is why I have kept solutions in these sheets. But when you're actually studying, I would suggest that you work them out, taking sufficient time. Okay. Yeah. So we have 0.25 into 4f minus 3 is equal to 0.05 into 10f minus 9. Okay, so we have to get rid of the brackets first. So we have to expand. So this is 0.25 into 4f minus 0.25 into 3 is equal to 0.05 into 10f minus 0.05 into 9. Oh. So what do we have here? What do we have here? What is 0.25 into 4? What is 0.25 into 4? Yeah, it is 1. 1 because 25 into 4 is 100. How do you quickly do it? See. 0.25 into 4. See, forget about the decimal points. There are two numbers after the decimal point. So for the time being, forget about it. Multiply 25 into 4. That becomes 100. Now bring in the decimal point. It's 1.00, which is 1. Or otherwise, you can think 0.25 as 1 by 4. A quarter, right? 0.25 is a quarter into 4. That is 1. So 1f is nothing but f minus, again, 0.25 into 3. 0.25 into 3. How do you do that? We have 25 into 3 as 75. It's 0.75. Right? On the RHS, we have 0.05 into 10. 0.05 into 10. That is going to be 0.5 f. 0.05 into 9 is going to be 0.45. Why? Because, again, same logic. 0.05 into 9. Assume as if there were no decimal points. So this is nothing but 5 into 9, which is 45. Now bring back the decimal point because yes. So that is 0.45. This is clear for you? Clear? Yes. So bring the variable to one side, bring the numbers to the other side. So we have f minus 0.5f, 0.75 plus 0.45. Sorry, it's minus. Bring this to the LHS, bring this to the RHS. So this is 1 minus 0.5 times f is equal to 0.75 minus 0.45 is going to be 0.30. 75 minus 40 is 30. Oh, wait. Did we make a mistake? No, we haven't, right? We haven't made a mistake, right? It's 0.75 minus 0.545, which is 0.3, right? It's 0.3. It's 0.3. Right? Now your f is going to be 0.3 divided by 1 minus 0.5 is going to be 0.5. So this is 3 by 5. This is going to be 3 by 5. This is going to be 3 by 5. Hope this is fine. Tell me. This is fine. Now in the solution part of this problem sheet, there is a mistake. Okay. So just rectify that. There's a calculation mistake in the solution part of the sheet given to you. See, there is some mess up here. So just rectify it. Okay. I'll soon share the updated sheets. The corrected sheets I'll share. Even in the last class, there was some typing mistake. Yeah. And now suppose you don't want to deal with fractions at all. You don't want to deal with decimals at all. How do you do it? How do you do it if you don't want to deal with decimals at all? So let's see how this can be done. See, we have 0.25 into 4f minus 3 is equal to 0.05 into 10f minus 9. So what do? I'm going to write this 0.25 as 25 by 100. And this 0.05 as, I'm going to write it as 5 divided by 100. Is that all right? 0.25 is 25 by 100 and 0.05 is 5 by 100. That's fine, right? Yes. 0.25 is 25 divided by 100. And 0.05 is 5 out of 100. Is this confusing? This conversion to decimals? Is this confusing, this conversion? Are you familiar with this conversion? Yes, you're familiar, right? I mean, this is not rocket science. I mean, 0.25 is nothing but 25 out of 100. 25 by 100. 0.25 is a quarter, which is 25 parts in 100, right? Yes. Yes. Tell me it's all right, then I'll move on to the next step. Cool. Now it's easy because you can just cancel off 100 on both sides. Okay. And here also you can do a cancellation. This is 5. Now your question is 5 into 4f minus 3 is equal to 10f minus 9. Absolutely no fractions, no decimals to deal with now. Isn't this easier? This is easier, right? Now you just multiply. We have 20f minus 15 is equal to 10f minus 9. And so we have 20f minus 10f is equal to 15 minus 9. So we have 10f is equal to 6. And your f is 6 by 10 or 3 by 5 or this is 0.6. That is the same answer we got. This is easier, right? This is easier, right? Yes. So that was our sheet number 5. So shall we move on to the next sheet? So in this question, you can have denominators. These type of question, you have denominators or fractions occurring in the question. So let's see question number 1, how this can be done. So we have 10x by 7 is equal to 5x minus 10 divided by 3. So how do you solve this? So please pick up your problem sheet number 6. Pick up your problem sheet number 6. 10x by 7 is equal to 5x minus 10 divided by 3. So what is the idea here? You have to cross multiply, right? You have to cross multiply. If somebody tells you a by b is equal to c by d, this simply means that a into d is same as b into c. Yeah. So we have 3 into 10x is equal to 7 into 5x minus 10. So we have 30x is equal to 35x minus 70. So bring everything to one side. So 30 will be taken to this side. 70 is equal to 35 minus 30, x, which is 5x. And your x is going to be 70 divided by 5, which will be 14. Yes. Fine. Tell me this is all right. Yes. Okay. Question number 2. We have 4a plus 4 divided by 7 is equal to minus of 2 minus 3a divided by 4. See, when you when you have negative sign for a fraction, okay, you can write it as either minus a divided by b, or you can write it as a divided by minus b, or you can write minus of a by b. Everything is same. Okay. So you just keep the negative sign with the numerator. Okay. And now you cross multiply. When you cross multiply, we have 4 into 4a plus 4 is equal to 7 into negative of 2 minus 3a. So this is minus 7 into 2 minus 3a. When you expand the RHS, minus 7 into 2 is going to be minus 14. Minus 7 into minus 3 is going to be plus 21a. LHS, it is going to be 16a plus 16. Yes. Yeah. So bring 16 to the other side, 14 to this side. So 16 plus 14 is going to be 21a minus 16a, which is 5a. And this is 30. 30 is equal to 5a. And your a is equal to 30 divided by 5, which is 6. 6 is our answer. 6 is our answer. Okay. Shall we move on to the next question? Yeah. Okay, cool. So we have 3m minus 8 is equal to 9m plus 5 divided by 2. Again, cross multiply. See, in the LHS, it's like we have 1 in the denominator. So we have 2 into 3m minus 8 is equal to 1 into 9m plus 5. So this is 6m minus 16 is equal to 9m plus 5. So bring 6m to the other side, 5 to this side. So minus 16 minus 5 is equal to 9m minus 6m. So this implies minus 21 is equal to 3m. So Rm is going to be minus 21 divided by 3, which will be minus 7. Yes. Yeah, cool. The next question number 4. Half 1 by 2 plus 2 by 5 s is equal to s minus 3 by 4. Yes. So bring 3 by 4 to the other side, 2 by 5 to this side. So we have half plus 3 by 4 is equal to s minus 2 by 5 times s. So this is 1 minus 2 by 5 times s. And the LHS, half can be written as, your common denominator can be made as 4. So this is 2 by 4 plus 3 by 4, which is 5 by 4. 5 by 4 is going to be, and 1 minus 2 by 5. 1 minus 2 by 5 is going to be 3 by 5. 3 by 5s. Now, how do you isolate s? For getting s, you have to take 3 by 5 to the other side. See, it's basically 3 by 5 being multiplied on s. 3 by 5 times s. So when 3 by 5 goes to the other side, it becomes division, right? And division by a fraction is nothing but multiplication by its reciprocal. So it is going to be 5 by 4 into 5 by 3. Okay. So your answer is 25 divided by 12. Okay. See, I want you to listen to one. I'll take just 2 more minutes. Okay. Then we'll leave. See, if you make a very silly mistake, say you see 5/4 here and you have 3/5 here, and say you get tempted and write 3/5 here, because you want to cancel off this 5. You have a strong urge to cancel off this 5, and so you carelessly go and write 3/5 instead of 5/3. You're going to get S is equal to 3/4, which is a wrong answer. But the thing is, most of the time, such wrong answers will be given as one of the options. Okay. In a standardized exam, if there are options, if there are different options given to a question, apart from the right answer, there will be three wrong answers, right? Three wrong options given, right? And those wrong options won't be any random numbers. Okay. They will make sure that if you make the slightest of the mistake at any step, you will end up getting a wrong answer, and that would have come up on the options, right? So should be very careful. See, it is natural. See, we have 5/4 is equal to 3/5, 5s. And when you take 3/5 to the other side, suppose if you write this as 3/5, and you feel good. You feel good because, yeah, see, 5 and 5 are getting cancelled off. So I'm getting a very neat number, 3/4. Much, much neater than 25/12, right? So don't make such stupid mistakes, because, even if you make the silliest of the mistake, your answer will be wrong. And that wrong answer would have come up on the option, come up in the options. Okay. All right. So your SAT is a complete different game. When you compare your school exams, totally different. So you have to develop that kind of attitude, because only final answer matters. Steps do not matter. You have to arrive at the answer in the shortest possible way, the smallest possible time. Okay. It is okay to use sneaky approaches. It is okay to use shortcuts, and you should use shortcuts and sneaky approaches. And only final answer counts, nothing else counts. And if you make the smallest of the mistake, if you make the silliest of the mistake, you're going to lose marks. There's no partial marking here. There's no partial credit here. Okay. So I also want you to develop this kind of attitude. Okay. We are starting early, because you have about 1.5 years before you appear for your first SAT. So we have a lot of time. Okay. So for SAT, we are going to develop this kind of attitude. Is this cool? I hope you understand what I'm saying. Yes. So I'll share a problem sheet with you in a day or two. Please go through it. Please try to work it out. That sheet, as we discussed today, it will have constants, okay, which may need to be evaluated. Okay. Those are easy questions, and we'll definitely discuss those questions in the upcoming class. Okay, then. See you. Thank you so much for joining today.